Today you get to drive in a giant pack of lumber on the build show today, and this is our ready frame package from BFS. Come on, let me give you a quick tour. This is everything we need to build the first floor on this house, and you're gonna be shocked at how quickly this is gonna go because we pre-thought about where every stick on this load goes. Check it out, see these labels, first floor package? This is gonna be each individual wall on the entire first floor on this load. So when my framers get done with this load, the entire first floor will get built. And everything is inkjetted and marked, so we know exactly where this is gonna go. This giant package is everything we need to build the first floor walls on this house. All right guys, this is episode 5. We're finally going vertical. The Reisinger build in partnership with our friends at Builders FirstSource. Let's get going.
A Build Original Series, in partnership with Builders FirstSource. The Reisinger Build.
Oh man, an exciting day, but I want you to notice how quiet it is on the job site. That's because we got Ready Frame going on. Let me introduce you to the head Ready Frame for all of BFS. This is Terry, who your title actually is VP of Ready Frame Solutions, right Terry?
That's correct, Vice President of Ready Frame Solutions.
So you've seen Ready Frame on the build show before. This is not new. You guys have been doing this for like 2 decades now, right Terry?
That's correct.
Why don't you walk through what the system looks like, and maybe you can explain kind of why we put the bundles from your driver in this special type positioning.
Absolutely, Matt. When part of the Ready Frame process is called smart bundling, so this is done intentionally. We run across jobs all across the country where we have framers that are doing this for maybe the first or second time.
Yep.
And so there's a learning process with that. So in putting the bundles down, we're helping them orchestrate the job from the very beginning.
I like it.
Okay, so if we walk around here, I'll take you to the first bundle.
Okay. So this first bundle, I'm noticing we've got green plate and I'm assuming top and bottom plates all bundled together. Walk me through how the framer knows what's what.
That's correct. So actually on your job, you have one different detail than we have on most jobs. You have 2 bottom plates, and I'll let you explain that. But we have the plates marked with an E for the exterior and P for the partition.
Okay.
And then the number 1 means it's on the first floor. The number 32 tells it where it belongs in the house.
Okay, gotcha. Okay. And so, you've got that full layout right here for the framer too to know exactly where those bundles
Yes,
go.
I do. I have the complete layout here. This particular wall right here is E100. Matt, that's this wall right here. And we'll walk over there in just a little bit. And we've actually marked on the slab already every one of these positions. So as they pick up the bundle, they know exactly where to put it. They don't have to walk around and look through the slab and look through the different parts and pieces, all right?
So let me explain real quick why the double bottom plate. This job, Terry, is slab top insulation. It's a detail that Steve Basic, my buddy's been doing for years, where basically we'll have 1.5 inches of Atlas foam on top of the slab.
Okay.
And then we're gonna do 2 layers of Advantech decking that are glued and screwed to each other and basically floating on top of that insulation. So what we're doing today is we're gonna frame all the load-bearing walls. Basically all the outside walls are load-bearing, and I have 2 interior walls that are load-bearing. And then once the house gets dried in, then we'll frame the rest. And so the double bottom plate is because we've got that slab top insulation, it's gonna give us a much more straightforward install for the carpenters.
So you've got a thermal break from your slab to your floor immediately.
Yeah, and the other thing I forgot to mention too is we're using Zip R on this project. So Huber makes standard zip system sheathing when they make it in 2 different sizes and thicknesses, and they make a version that has insulation pre-bonded to it. And so we're using that in an R6 configuration. So it's 1 inch of insulation bonded to 7/16 Huber zip system on the outside. And so our bottom plate is a little wider to accommodate that, and you'll see later it's going to actually drop onto the bottom plate. And when you look up, or when you're thinking about the house from a bottom-up view, there's no foam showing on the outside of the house. It's getting encapsulated or captured by that second or that first bottom plate, I should say.
Got you. So that brings back when you have a special design You let us know what that is, and we design the house to that specification. So as you're going to see, all this initial plate that's being put down is all 2x6. And as we go through the house and we start framing the walls up, we're going to be framing with 2x4. So you're going to have that ledge to set your product.
That's right. We actually ripped that bottom plate by a 1/2 inch. That'd be exactly 5 inches, and you'll see later. But we have some 2x6 and some 2x4 exterior walls. Most of the house is 2x4, and I think that's one of the big benefits of working with Builders FirstSource is the ReadyFrame crew. As Justin and his team put this into the computer model, we can do whatever we want. We've got some staggered stud walls on the second floor between bedroom spaces. I've got some 2x6 walls that I wanted to show some different insulation details. All that's accommodated with the model. And you're gonna see in a minute too, you can do whatever you want for headers, for sheathing, whatever. As long as it's in their catalog, you can pretty much frame it that way.
Got it, got it. So a couple of bundles that are left here to be placed on the slab right now. This right here is exterior wall 121.
Okay.
It's marked with your bottom plate and your top plate right here. You got your bottom sill, you got your top pieces. Everything's right here.
And these have been inkjetted at the factory to actually show us what stud is going where, right, Terry?
That's correct. And it also tells us what length that is. If you ever needed that, there's no need to have to pull a tape measure on it. It's already listed right here.
That's really awesome.
And it tells us what the length is on every single piece as we go through.
And that's why we've got a bundle of pre-cut studs over there, because this top and bottom plate, all they're doing is grabbing this, then they grab how many studs they need off that bundle.
That's exactly
and boom, now we've got a wall pack ready to go, right?
That's exactly right. So what we've done now, Matt, with the smart bundling, we had your very bottom plate, we'll call it, that's already being applied. We had the exterior top plate, bottom plate in here. We have our interior bottom plate, top plate in here. When we move to the next bundle, you're going to see the same number again, like E104. So that's telling us it's an exterior wall, but this becomes all the components then for that wall.
Got it.
All right. So now we just, again, we pick it up and we go to where it belongs on the house. And then on the back one here, we have the pre-cut studs, and we also have the headers already pre-cut for you as well, Matt. In this particular case, you've selected to use LVL headers, and we can do that to whatever the plan calls for. We can use dimensional lumber, we can use engineered wood products, we can even use a engineered truss in order to make a header.
Makes sense.
Yep.
And I love how everything's inkjetted, so I know, like if I look at this bundle 104 right here, it's labeled jack stud, sill cripple, jack stud. So then everything I need is right there, and I'm gonna grab that header off the bundle. Right. And boom, there's no saw needed. The only time we're going to hear a saw on this job really should probably just be bracing, right?
Probably so. Absolutely. When we get beyond the frame, when we get to sheeting, that sort of thing, then the saws are going to kick in on your job. So number one, it's going to be a safer job. Yep. We don't have that saw activity, and then we don't have all this waste. We're optimizing the lumber and putting it in the house, not in the dumpster.
It's pretty quiet around here too, isn't it?
Yeah, it really
pretty
is.
Nice.
Absolutely. It's kind of warm though, but
it is a little warm. Another thing I want to mention is, Terry, we didn't have a perfect slab here. We had this wonky design where we're reusing some slab. We topped it. We have a couple imperfections, and I think it really speaks a lot to the ReadyFrame package that we're able to accommodate that, and that you guys realize ahead of time, look, there's no perfect concrete job.
Right.
So all this is modifiable in the field relatively easily.
That's right.
Compared to, let's say, a pre-framed wall that comes out on the job, you're really wanting that concrete to be absolutely perfect.
Absolutely.
We're still basically framing this house. We're just doing a lot smarter and a lot faster.
That's right. That's right. When you're talking about panel construction, you basically have to deconstruct at that point. And panels that come out to the job site with sheeting already on, it's a tough job to pull all that stuff apart. With ReadyFrame, we still have the flexibility to fudge it around if we have to a little bit. We want it to be square. We want to eliminate the saw, but we still have that flexibility with this slab.
That's really smart. Now, what are the markings that I'm seeing on the slab? Somebody went around with a Sharpie. I don't know if that was you or one of the framers, but I'm seeing all the numbers. These are the bundle packs, right?
That's correct. So the bundles itself, this is exterior wall 100.
Okay, so that's where that bundle is right there.
Marked right here. And when we design this house for you, we design it from left to right. So you lay this product down, the markings are up, you can read them left to right, you fill in with your studs and your components, stand your wall up, all the markings are on the outside, and then you sheet it.
Smart.
Yep.
Love it.
And we follow that pattern consistently all the way around. So you're not jumping from 100 to 101. to 102. It's all in numerical order.
Yeah,
now,
makes
the
sense.
other really nice thing about Ready Frame and the design element, let's say we talked to the framer and we had him involved from the very beginning, and he said, look, I want to start back here. At that point, we place exterior wall 100 back here, and we start moving
gotcha.
around.
Yeah.
So we're very flexible in our design.
And we're in a tight infill lot here, Terry. So being able to think about that process of framing, for instance, there's no trusses on the job yet. I don't have any second floor, I'm talking floor trusses, that is. There's no second floor walls here yet. We've talked to the framer ahead of time and said, hey, let's stagger those. And we've got a drop coming in a couple of days. We've already said, hey, we actually might need to bump that a day depending on our progress.
Yeah.
Is that normal when you're doing ready frame?
Yeah, the key to construction when you're in an infill lot like this is flexibility.
Yeah.
All right. One of the reasons that Ready Frame really works for this project is because we have enough space for our bundles.
Yep.
We don't have enough space for panels to be out here.
No,
okay.
we don't.
And so by placing all this down, and we still save you some extra room here to do some layout.
Yeah, that's right.
Okay.
Terry, let's let these guys get started on some first floor walls and we'll come back and narrate some more.
Very good, Matt. Thank you.
Here's a bottom plate detail I learned from my buddy Steve Basic that I love to use on every house. What you're seeing is the guys are using just an inexpensive sill sealer. This is Owens Corning's product. They're hammer tacking it just to the back side of the bottom plate so that they can flap it up and they can run a bead of sealant along there. We're using Sashco's Lexel. If you're not familiar with this product, their kind of funny phrase they say is this sticks to almost everything. And that's definitely true. If you look at the list on the back here of what it sticks to, concrete, wood, and like 30 other things. This is a really good product. So what it's gonna do is it's gonna go in between the wood and the sill sealer, and then you're gonna see we're gonna flap this over, and we're gonna put a bead on the concrete as well. He's putting a nice fat bead where the two boards are coming together. Now he's gonna put it on the concrete all the way across. And what that's gonna do is that's gonna give us a much better air seal, and it's gonna give us a little bit of bug protection as well. We're trying to put a nice continuous fat bead all the way across where that bottom plate is. And that, for the lifetime of the home now, is gonna protect us from air infiltration at this spot. You know, that concrete, it looks flat, but there's some small undulations. And this is like 3/16 thick, it compresses. But this is gonna take that and take it to the next level. This is a great detail. I think we've gone through maybe 2 cases of Lexel. So maybe for 5 cases on the whole house, we'll be able to do this on all the perimeter walls. And now I've got some lifetime protection for both bugs and air. This is a great detail.
So Matt, we're starting to roll out your walls and starting to put the actual frame of the components together at this point. So as you can see, as we talked earlier, we have our walls that are already marked. We put them in position, and everything is marked exactly where the studs go.
Yep.
And it tells us the length of every piece that goes in there. This particular wall is all studs, so you can actually count the number of studs you need here very easily. This is done. This wall took like 3 minutes to get done.
Amazing.
And we're moving on to the second wall.
So
already.
this was all wall E100 that had the top and bottom plate.
Yes.
Then E101 is next, and this was a short wall too. And you're also marking, Terry, where we've got California corners, where we got wall intersections. And they pre-nailed up that California corner right there.
Exactly.
And they nailed up this 2x6, which is a wall intersection. We could have done ladder framing there.
Exactly.
And then this is now set up for our next third wall right here, E103.
Correct. And this one is telling us right here that we've got a window right here.
Yep.
It's a 3660 window.
Yep.
Is what it's telling
Yep.
us.
That's
So
pretty awesome.
it has all the information is really that we were looking at in the booklet that had the elevations. All that material is right here.
And he's grabbing pre-cut studs off the pile to drop them on.
That's correct.
And then he's going to have to get this component pack out too, right?
Right. That was the third bundle that we showed you over here earlier that has all the components for the interior and exterior walls. And again, it has the same wall number on it there. What is this one here? What's that number?
This is 102.
102, and we've got it marked right here, E102.
E102,
So we can
yep.
bring all this material right over here. So it keeps the number of steps they have to take, takes it down. Look, they've already grabbed your header.
Super fast.
Fantastic.
Love it, Terry.
So what we have here is the Ready Frame booklet that has come to the job site with the material that is going to show you the overall layout of the house. This particular wall right in this area is going to start right over here. So when we come through here and we label the walls, so that here is E100 and E131. That is actually this intersection of the house right here in the front corner. Then when we come through here and we're labeling these walls, E100, 101, 102, we'll flip, let's say, wall E102, and now we show you the elevation of that wall. It shows you all the headers, it shows you the trimmers, it shows you the king studs, it shows you the sill cripples, and then it also has this all material labeled down below. Interestingly, and what helps these framers go faster is all of this information has been printed on the bottom plate and the top plate. And then all of this information then will correspond to how we deliver the material. And if you recall, we called this smart bundling. So the way the material comes to the job site, for example, this is an exterior wall 122, and this is my top plate and my bottom plate. And then you can see all the different studs that are in this particular piece, and it's labeled right here what the length of every single piece is. Now, the E is for exterior, the 1 is for the first floor, and this is wall number 22. When we get to an interior wall, for example, this is going to be P106. Again, we have the bottom plate and the top plate, but a P is going to be for our partition interior walls. So this bundle here has all of the bottom plates and top plates in it. Our next bundle is going to have all the components in it that go to these individual walls as well. So we just started framing on the house, and this particular one here is marked as E104. So we started on wall E100. This is going to be one of the next units that's grabbed from here. The really nice thing about this though is when you're laying out the materials, you don't necessarily come over here and look for an individual bundle. Remember that we already labeled the slab with all of these part numbers, and by doing that, we can simply grab whichever bundle we want and place it where it belongs. So we're not wasting time, we're not wasting steps trying to figure things out. Again, this is all part of the smart bundling process that we've thought through by talking with a number of different framers over the years and coming to the very best solution in order to help our framers.
Dos, tres. I'd like to point out that we got back from lunch and started framing first floor walls about 35 minutes ago, and we already have 3 walls stood up across here. This goes incredibly quickly. Check this out too. This is a detail that Ready Frame did for me that I like to do in all my houses. This sill, the cripples got cut on a 5-degree bevel. It's gonna be a little hard to tell, but if you look directly on, you can see that 5-degree bevel right there. So this sill has pitch to the outside. This was done at the Ready Frame factory for me, so I did not have to cut those cripples. Those are already pre-cut. And now you can get a feel for why we did this double plate detail. This plate that's sticking out a little further is gonna receive my zip R. Now, full confession though, we made a little bit of an error in the foundation. You got a little bit more air under there than I expected, so we're gonna have to do a fix. Stay tuned for that. I'll have to get my engineer out. I suspect we're gonna need either a ledger or an angle iron down there, but that's part of construction. I'm not sure if that was our mess up or the concrete guys. We gotta figure that out, but you can see we've got too much of a gap under here. Looks like our foundation was off by 1.5 inches. So we'll figure that out. But this is now the receiver for the zip R, which will go on the outside of this. And we decided to sheathe this after the walls get stood. So stay tuned for us sheathing. Let's keep going on walls. All right, Terry, what am I doing? Hang on a sec. 1 second.
That's better.
Ah, that's better, Terry.
That's better.
5:05, day one.
We didn't hear a saw all day, but we listened to this guy. It was all right, though.
We needed that for drilling into the concrete and running a table saw to rip down some bottom plates, but
worked out well.
Worked out well. What do you think, man? We made some great progress today.
I tell you, for day one on this project, dealing with the bottom plate as we did, getting all that product lined up.
Yeah.
These walls went up fast this afternoon. These guys did a great job.
Madera guys did a real nice job. So we got all the left side framed. We got this back wall framed. This is a portal frame, so it still needs a LVL header all the way across. And we got about all the way to the garage.
All the way to the garage.
What do you think about tomorrow?
Well, I think tomorrow morning the rest of these walls will go up. We'll get our bearing walls in, and their trusses will start laying out.
Yeah,
It'll be real
think, Terry,
nice.
had we not had to do that double bottom plate detail, and I had a couple things off of my concrete that could have been better. Had that been a little tighter, we could have almost rolled trusses tomorrow morning.
Yeah, but you know what, Matt? This is why it's construction, right?
Yeah,
you always run into things. There are things that you don't really foresee that happen. You make adjustments,
Yeah.
but it's all been good.
I mean, that's the beauty of Ready Frame, is that we're able to make those adjustments. This is still framing. We still need smart carpenters. We still need smart builders.
Yep.
But we're doing it in a way that's definitely faster. I can tell already we are rolling on this project.
Absolutely. And then once they came in and they started putting up these exterior walls this afternoon, it just went boom, boom, boom. They really grasped it and took off really fast. I'm impressed. They did a great job.
They did a great job.
You
Let's
bet.
go get some dinner. We'll see y'all here tomorrow.
All right, take care.
All right, y'all, day two of our Ready Frame package. It's about 9 o'clock in the morning. We started at 7. Check out the amazing progress we got going on here. We are almost done at this point with our first floor wall framing. Check this out. We got the last few walls. Here's one going up right now. This is the outside garage wall. We got a big header going on in the garage as part of our portal framing, so that's gonna take a little bit of muscle to get in place. But big shout out to our friends at Builders FirstSource. We got Billy on the spider back here, who's moving some material around for us because my floor truss package is here. Very tight site. You know, we're here in a established 1970s neighborhood. I don't have any room on the site. My fence is on my setback right behind the sidewalk. I can't drop stuff at the street. So that's one beauty of this Ready Frame package, is we can really space out what we need when we need it, rather than dropping huge amounts of lumber everywhere and picking off the pile. I think the other thing that's really interesting about this is, if you think about us starting yesterday at this hour, we're really only kind of one workday in, because it took us a while to get the bottom plates on. So when these guys say this is 40% faster, I really believe it. So if we spend a little bit more on this package than a traditional lumber pack, which there's probably some addition here, I don't know the exact percentage, we'll ask BFS later. But think about the labor savings. Now, I pay Bill and his guys on a cost plus basis, or a time and material basis, and we've worked together a long time, so that's a savings that's directly to my bottom line as a builder. But let's hang on a second till the trusses start coming in, and I'm going to talk to you a little bit about the floor trusses we're using. Billy's bringing my truss package in, and if you're not familiar with floor trusses, a lot of you in the Northeast are used to using solid sawn lumber, you know, 2x10, 2x12. Some of you have gone to I-joist, where you've got a top and bottom cord that's usually an LVL material, and in the center is some type of OSB. I think Billy's waiting for us. Let's back up here a little bit. But what we're using, and what we use a lot here in Texas, because we have no basements, you know, we're almost always slab on grade foundations, is an open web floor truss. So BFS makes this at their truss plant. So this integrates with our Ready Frame package. I think Billy, you coming right here, brother? Billy's coming right here. Let's scooch back a little bit and get out of his way. These are not dissimilar from a roof truss, right? It's an engineered product. We tell them how stiff we want them. We go for an L/360 stiffness rating. and the engineer designs this span to span. Now Steve Basic, the architect on the job, designed this house to have as little bearing walls as possible on the inside. We just have 2 bearing walls in the center for these trusses, but everything else is spanning side to side. And so that gives me the ability to have a very open web for my mechanicals. And you're gonna notice as Billy drops this off here, we'll see in a second, there's a square notch that's usually in the center third somewhere. So I've got one really big opening that I can get a big trunk line. I think I've got a 10-inch trunk line. And we spent a fair amount of time in pre-construction with Justin, you probably saw that on the videos earlier, trying to figure out where all those mechanicals were gonna go so that we had a clash detection report which showed, hey, we've got some issues here. Let's redesign the trusses, let's figure out the design so we can get everything through. And we also have one really big girder truss on the back of the first floor holding the second floor up, which allows me to get access between the attic that's in the back of the house and the floor system here. So hopefully, if all goes well, we'll be setting some floor trusses sometime after lunch. All right, so here we are like 24 hours in on the job, right? We really started in earnest at this time yesterday. We're on day 2. This is about the last wall that will get framed on the first floor before we start rolling trusses. But if you didn't see this, let me just show you real quick how awesome this system is, that the framers can basically read the inkjet printing on this bottom plate and know exactly what components to grab. So for instance, this king stud, you can tell there's no markings on this king stud. This is just straight off the pile right here. So we've got a pile of pre-cuts for a 9-foot ceiling. So that's straight off the pile. On the other hand, this jack stud right here is labeled jack stud, and it's labeled on here, this is 8 foot 10 inches, because that's been lowered the height of the header that's gonna rest on that jack stud. And then next to that, you can see here that's labeled C as in cripple. This is a sill cripple. The height on it is 1 foot 10.2. 1 foot 10.2 is right here. So we know this is the exact sill cripple that fits with this. And then all these cripples, by the way, have been cut with an angle on the pre-slope. BFS did this for me. This is a design that I really like, and you could do this on your ready frame jobs as well. This is a 5-degree bevel on this sill cripple right here, so that when I put my sill on, the sill is not flat. See how it's not flat? It's gonna be at an angle when it's all nailed together. And now I've got a slope sill straight from the factory. Isn't that nice? And then lastly, these headers are all pre-cut as well. And I specified that I wanted Boise Cascade LVL headers. This header's also pre-cut. It's gonna drop right in. Now the framer still needs to know where these things go. He still has to be a smart framer. This is not taking the craftsmanship out of framing, but what it's doing is it's really speeding up the savings on labor on this job, which is a really big deal. Now this crew can be quite a bit more efficient and effective. And this being 24 hours into the job here at 9 a.m. on day 2, you can really see the speed of ready frame. All right, mid-morning day 2, all the perimeter walls are framed. I've got a couple of load-bearing interior walls like this one. This wall is gonna separate the master or primary bedroom to the stairwell. And a couple things I wanna point out. Double bottom plate on here. BFS did that for me because I've got that additional floor thickness. Remember, on top of the slab, I've got 1.5 inches of Atlas insulation. Then I've got 2 layers of 3/4 Advantech. So that's why we double bottom plated it, to make up that same 3 inches. We're gonna put sill sealer on all these interior walls that are bearing onto the slab. And we're gonna wait on the rest of the interior partitions until that insulation's down to get the most amount of insulation. But this is really interesting. This wall, you're noticing, has a 2x6 bottom plate, but all these studs are 2x4s, and here's why. Look, this one's labeled as 2x4 down, 2x4 up, 2x4 down, 2x4 up. This is staggered stud construction. We're doing this for sound insulation reasons, so that we'll have less vibration from those studs between one side of the wall and the other. And then we've got some load-bearing columns on either side of those. So it's not gonna be perfect from a sound perspective. But again, we're only putting down the load-bearing walls where we need to so that we can set trusses, hopefully, as we come up to lunchtime. All right, y'all, day 2, another great success, but I gotta show you this. 103 is the feels like temperature. It is May in Austin, Texas, and we are having an unusual hot snap this week, which coincides with framing. So I'd say the crew, even though we didn't quite roll trusses after lunch like we thought, they absolutely killed it today. This heat and humidity are crushing us out here. It's been really hot. A couple things I want to point out now that it's quiet and the crew's just left for the day. It's really fun to see how everything lines up perfectly from the computer, right? We saw the digital tools and we were back at the shop with Justin, to everything on site here. So for instance, this double bottom plate, this is kind of a new detail. I don't think ReadyFrame has done this before. This is something that I really like. Steve Basic thought this up, where we've got this wider sill plate that captures the bottom of our zip bar. But it's cool to see, like, look, we got our 2x4 cripples that are pre-cut right here. We've got our 2x4 jacks and cripples that are pre-cut right here. And just in case I didn't say this before, in case anybody's wondering, see how there's 3 numbers on there? It says 1 foot, 10 space 2 inches. The computer doesn't do fractions. So what you're actually seeing on this cripple right here is 1 foot, 10 inches and 2/16 of an inch. So this is actually 1/10 and 1/8 is how this cripple stud got cut. And look how perfect that is. Nice and beautiful out on the job site. The framing is really precise, and I think it's really fun to understand the nomenclature when you're on the job. Now, as for the inside, remember I mentioned we're not going to frame any of the interior partitions until we get the subfloor and the insulation down. We had to frame these walls because these are load-bearing walls. So you're going to see trusses bearing onto these walls. And this is that staggered stud wall that I showed you earlier now that it's in place. You can see we've got that double bottom plate that's a 2x6, but I've got my studs here staggered. As we get into a later episode, we're going to be talking about the USG products we're using on this house, and we're going to talk to you about some soundproofing we're doing between this loud stairwell and the primary bedroom here. And then I've got 2 bedrooms above us that are also on the stairway. We're going to be using some USG products and a couple of other ancillary things that I like to do to really take the quiet home to the next level. If we think about it ahead of time, it's not really a budget buster. You do need to spend a little bit more money, but you'll see how I can use some fairly straightforward products to get some really good soundproofing results. This is our girder trusses. If you haven't seen this before from the model, this is on the back of the house. And this is carrying that load from the 2nd floor and bringing that load down in the foundation. So this PSL column here, that PSL column there, this is bearing that weight of this girder truss. Justin and the guys at BFS helped our team design this so that it would be open where we needed it to, but also this eliminated the use of steel and the use of a much more expensive, triple ply LVL or something like this. This is, even though it's quite big and large, this is a relatively inexpensive way to bear a lot of load on the back of the house. That being said, we're rolling trusses first thing. I'll see you guys back here tomorrow. All right, we're not fooling anybody. We're not actually setting the trusses, but we do get the privilege, Terry, of bringing the last floor truss into the house. How about that, dude?
Nothing like the last floor truss.
So I'd like to point out that it's day 3. It's 9:25, Terry. And this is the last floor truss to go in. Holy cow, this has been fast.
Boy, it goes fast when you have all of your pre-built components on top of ReadyFrame, and now you got all your trusses built. They just go in place one right after the other. These guys haven't stopped moving all morning long.
Yeah,
it's been fantastic.
My Videra guys do a great job. Let's walk them through real quick, Terry, what we've got. So all the bearing walls are in place, and then these guys set all the beams first, right?
That's correct.
Because these are hanging off the beams, and obviously we don't have hangers in yet, but these are gonna have some Simpson hanger hardware that's gonna go on there.
Correct, that's right.
And then
they're just secured in place.
We're gonna be decking by like 10 a.m. on day 3.
That's pretty awesome.
That's
You
pretty
to help
crazy.
speed this thing up. And the really cool thing about this, everybody's been safe.
Yeah.
So we're faster, we're safer,
Yeah.
and and the other part, we have no waste here either. Every part and piece is being put in place. All this bracing that we see is all going to be utilized throughout the house. This is going to be really cool.
I
man.
should have put a dumpster cam in there, Terry.
Oh, that would have
'cause,
been good.
I mean, that little dump trailer that I've got only has a few boxes and a few straps and maybe 3 or 4 chunks of wood, and that's about it.
Yeah.
The amount of waste is almost zero on this.
Yeah, exactly. We've been here 3 days, and the amount of saw time that we've actually, if we recorded it, we'd be less than 5 minutes. There just hasn't happened.
That's crazy.
Yeah,
It's crazy.
It's been really good.
We're about to start decking, but I do have one full confession to make, Terry. How about
Okay.
we show these guys something on the side of the house that we were talking about earlier?
Okay.
So we talked about our double bottom plate detail,
Yes.
where the purpose of the double bottom plate is a little bit twofold, but the main reason is it's capturing the bottom of our zip bar. So our
Right.
sheathing on this house is 1 inch insulation that's bonded to zip. It's called zip bar.
Yep.
We're doing the R6 product. And if you look at the base here, we're overhanging by, I don't know, 1.5 to 2 inches.
Yes.
Something like that. So our 2x4 wall has good bearing. We're right on the slab there.
Right.
But this bottom plate is sticking out. But guess what? This bottom plate is not bearing any weight. The 2x4s are.
Correct.
And you can also see my really ugly slab connection here, right? Because Terry, this is the original 70s foundation.
Yes.
This
Yes.
is my 5 inch, or actually it's probably 5.5 inch topping slab. You can see my stego in between there. So we're gonna clean this up. I'm gonna cut off these nails where we jackhammered out the fireplace. This all needs cleaned up.
Just clean it up.
It just needs cleaned up. And
Yeah.
the original foundation had what we call a parge coat. It's basically stucco, right?
Yeah.
It's a stucco coat in the foundation. So we're
Yeah.
gonna do some cleanup on here. We'll build this up by 1/4 or 1/2 inch. And then actually, I kind of like that this is sticking out because any water that sheds off the house is gonna wanna shed off the foundation rather than rolling down in that joint
That's right.
in there. But
That's right.
if I were to do this again, Terry, I think I would have worked with the Ready Frame guys to actually make this a little more flush
Okay.
rather than having the bearing flush. But you know what? It's not that big a deal, man.
It's not that big a deal. And the really nice thing about Ready Frame is that we can make those adjustments. Even on the job site, if something has to be adjusted, we can make those adjustments. We don't
Yeah.
have to tear stuff apart. We
right.
simply open the bundle, make sure everything is right, and then assemble. So
And
we can make those adjustments on the fly.
And I think that's a great ending point for this video because we've got a part 2 coming up on this, Terry. And I think it's really important for us to get across to the audience that Ready Frame still requires a smart framer, still requires a good craftsman, still requires a good crew. Could be a slightly smaller crew. They're going to be a lot faster.
Yeah.
But this doesn't eliminate the frame carpenter.
No,
This
not
isn't
at
just
all.
crane in 5 panels and the house is built. We're still basically building it the way I've always been building. I love stick framing. This, to me, feels like a really well-built, solid house. I love this system, but it sped us up big time. I mean, the fact that it's, 2.2 days into the job, let's say.
Really good.
2.25 days into the job,
Yes.
and here we are decking.
And this is the first time that this framing crew has ever used Ready Frame, and we're able to help them speed it up. And it was amazing to watch from the first day to the start of the second day to even this morning how fast they just picked up and started moving right through the house. It was
Yeah.
really good.
Big time.
Yeah.
Terry, let's go back to the studio because we actually spent a bunch of pre-planning time with Justin and Steve Basic, our architect.
Okay.
And now that you can see all the trusses in place, that layout was very specific, and every piece that's in the air there, every 2x4, has a specific location because we've got pre-planning for both piping, electrical, and for HVAC, and you can kind of start to see that now. So let's actually end this video here, or end this portion of the field here, and let's get back to the studio and see everything that happened prior to this.
Fantastic. Sounds really good, Matt.
Thanks, Terry.
You bet.
Okay, y'all, we are back. It's been 2 weeks. Justin and the BFS team have spent some time working. What do you got for us, Justin?
Well, Matt, as we met 2 weeks ago, we sat down with Steve and we kind of laid out the mechanical, electrical, and plumbing.
Yep.
what we've done is then stored that in my BLDR.
Okay.
As you know, it's a revolutionary platform for builders to kind of single source documentation.
So what you're looking at here is what a builder's kind of home screen would look like on my BLDR. My plans are stored there, so that's these plans that we looked at last time.
Correct. So last time we met, Matt, we met with Steve and we laid out your mechanical, electrical, and plumbing on the vibe board.
Yep.
We're then able to store that documentation in here, so we have your layouts. And then what we did is we took the model that we originally did, the 3D walk of the house, and we were able to store that in here. The other thing we've done is with our partners at BFS, or with our employees at BFS, we've taken and sent it off to them. They've designed your advanced componentry, being your truss and your ready frame, and we've got that baked into here as well. So you're truly able to do a structural walk with mechanical, electrical, and plumbing overlaid, and we're going to show you the results.
And so what we're going to see is the actual truss design, truss layout. All the engineering's been done by you guys too, because when you do my trusses, you're also doing the engineering, the load calcs for that, right?
Correct. Yep.
And then just a clarification, this meeting that we're having kind of in front of the camera could happen in my conference room. Lindsay is my outside sales rep for BFS. And Justin is a manager, a higher up, let's say, on the digital side. But normally what would happen is this meeting would happen with Lindsay and the BIM coordinator that did all these drawings, correct, Justin?
And either we go down to and meet at our offices at Builders FirstSource, we could do it at your office, and even if need be, we could do it virtually. So
makes sense.
And then I have a BIM coordinator. In this case, it was Kevin that then modeled this in for us, and we want to kind of show you the output of that today.
We're all waiting with bated breath. What do you guys think? This is going to be fun. What's the output?
All right. So the first thing we do, again, was we create that model, and we've ran a clash report based off of that. So we kind of show you that, hey, we had 337 clashes.
Okay, so this is a document that came from you guys.
Correct.
That after Kevin did the design then goes, oh, darn, we've got pipes hitting pipes, and we're working all this around the actual framing that's going to happen. And this report's saying, okay, we got to work on some things.
That's correct. Yeah.
Got it.
So, and you'll notice here that we kind of brought it down to 88. So we know some things can natively be solved. We don't have to bug you with.
I gotcha. So in other words, Kevin's found originally there was over 300.
Right.
He figured those out. We got it. But now we still have 88. Some minor, some major things that need work on.
Yeah, and to be one thing to be clear, we don't change any design. We're just here to report to you what it looks like structurally combined with the mechanicals and that laid in.
That makes sense.
So we then come to you, which is this meeting, and go, hey, how do you want to resolve this? It's your build. You got to work with the stakeholders. Of course, we have our components in, and one thing we do know is structure can't move, so we got to work around that.
That's right. Now, Tim, you said earlier before we started this video that we kind of tasked the architects, Steve and Chelsea, with something a little bit out of the ordinary here. Will you recap that for us?
Well, effectively, they were asked to design architecturally a house that fit well in the neighborhood, and it's a 1980s neighborhood.
Yep.
So the architectural styles are a little traditional.
Yeah, we're not doing 14-foot ceilings and all this kind of weirdness.
But at the same time, we wanted an interior that was somewhat more modern and open, and we wanted to try to move all the load-bearing walls as much as we could to the outside.
Right.
And so that created what I like to refer to as structural gymnastics to achieve that effect on the inside, and that's what really caused the majority of our clashes.
Right, because now we've got all this structure that is making a wide open space.
Right.
But because of that, now we've got some issues fitting all our MEPs in there.
Right.
And I want to make mention that what we're about to see here is something that builders are not used to seeing.
Yeah.
It's very rare that we get an MEP layout, and almost never one that's coordinated. Maybe once in my career that was coordinated with framing. So with that being said, can we see the model? We're all waiting with bated breath.
Yeah, and just one thing to kind of show you real quick is that in this documentation here, we actually do show you in the model where the element is.
Okay.
And we break it down kind of by clash, and then this element ID is viewable in that model.
Okay.
And so let's take you into the model and let's kind of look at it here and kind of see what we found in this, and we'll be able to kind of walk through this and show you kind of look and so, hey, here it is. Here's the model with everything modeled into it. So,
and you could actually move this, change this, manipulate this too, right? This isn't just a PDF image.
No, it's not a PDF image. This is interactive. We can store comments in here as we begin to coordinate today. And we'll go ahead and spin that around and just kind of take a look, and you'll just see that it's really interactive. We have comments stored in here, kind of in anticipation of our meeting, going, hey, these are some things we got to really talk about today.
Yep.
Things that'll cause you issues on the job site.
Oh, man. Hold it right there, Kevin. Come back 1 second on that. By the way, just so you know, Kevin, our BIM coordinator, is standing by. He's the hand that you can't see working on this. But check this out now. This is all our sticks for the house. All our 2x4s, all our trusses, and hold right there, Kevin. Look at that view. I can now get a glimpse in through that. None of the sheathing obviously is on yet in this model. So I can see these pipes, green and blue. I suspect there's color coordination. Some of these are showing different things.
Absolutely.
But all those are laid into the framing now.
That's correct. All right, so Matt, what we have here is you'll see we have the structural model here, and you have all the mechanicals inlaid to that so you can see it in a 3D view.
That's really cool. Love it. So then walk us through that. What does that look like? And then those clashes on that clash report, do we actually look at in this meeting those individual issues and try and solve those?
That's exactly what we do. So is, again, you with the other stakeholders involved, we want to make the decision about how we solve for that, how we look at the clashes. And what you'll see here is that we can pull up that report ID with that clash, and we can kind of go in and search by that. That's what we handle for you, though. We don't expect you to be software extraordinaires, but we'll help you kind of collaborate with this. And so what you're seeing here is that we have the ability to slice it, dice it, look at several planes of it, including do a first-person walkthrough. And we have it layered in here so we can begin to kind of turn on and off layers and really kind of hone in to the piece that we want to talk about.
Turn on and off layers, meaning like the electrical is one layer, the plumbing is one layer, HVAC's another layer. And we didn't...
And we kind of see some of it over here when we can actually look at it and turn pipes on and off. Fixtures, right? We can turn structural components on and off. So we have all that kind of separated in here in the template, and then of course, we've got all the sheathing turned off, fit and finish on the outside.
Gotcha.
So we're just looking at the base structure with mechanical layouts. And you can see here that we can dice it by trade as well. Right now we want to look at it just from the clash report of everything involved.
I also want to note that these trusses are actually, as they're going to come, they're clipped at the wall.
Yep.
And so we're doing monopoly framing on this house, meaning that my wall sheathing is going to go up and actually touch my roof sheathing, and they've modeled that just like that. So we don't have any rafter tails poking through like you would in kind of traditional framing.
Correct.
So all that's to the money at this point, right?
Exactly.
Okay.
Yep.
That's awesome.
And through our intake meeting we had a few weeks ago, we learned that these are your preferences. We want to make sure we model that. That is the other part to check here, is to make sure we have it framed the way you would frame it in the field as well.
Right.
So
that makes sense. And last question for you before you keep going on that clash report. We didn't have earlier in this episode our electrician here, but I understood, or I thought I understood, that you guys were taking the electrical plans and putting that on there. Is that electrical in here as well?
Yeah, so we'll see the little boxes here. We don't obviously wire, model wiring, but we do show you box locations, light locations. That's where you're going to see your clashes. And
so my recess cans are in here too.
They are. The recess cans are in here. Yep.
Gotcha.
So
that's pretty cool.
And we had 80 or so of them on the clash report. Those are easily moved, but again, we want to just go through there and perfect that. So when we do get the layouts back out to you, the supplemental layouts, the trade knows to the inch of where he's supposed to put everything.
Which is really important too. Like Chelsea and Steve work together on the reflected ceiling plan.
Yep.
And in her mind, she may have a really specific layout for those cans or a location for those. And if a truss is in the way, we may want to no problem move the can, or we may want to actually go back to you and say, no, actually we want to change this layout because this is really important to coordinate, whatever, an art light or something specific. Am I right?
Right.
Yeah.
Okay.
Yeah. That's the beauty of this. It's collaborative, right? And instead of figuring it out in the field, we're going to figure it out in the AC.
Yeah.
And again, the idea is to get rid of variance, get rid of cycle time loss, and to really make you an engaged, informed builder. You know, a lot of builders talk about builder of choice. To me, this is clear cut about what puts you above every builder out there.
It's unbelievable.
You know, and it makes your trades want to work for you. So we think that's a really important piece of this.
So let's actually go in and show us a few of those. Let's see if we can solve for some of those problems and actually give these guys a glimpse on what that meeting would look like.
Well, the first one that we're kind of highlighting here, and as we kind of go down that clash list, is we'll see here that we've got kind of a girder truss that's created here. As we talked about earlier, Tim, we kind of have that challenge of trying to put all the shear to the outside of it, all the vertical load to the outside. Well, in doing that, it created a large girder here. And with our other trusses, with the rigid duct that Steve designed in, we can have the clash very apparent here, and we can see that right here. So we're going to have to solve for this.
So let's orient for the viewers then where that girder truss is. This is the back wall of the second story of the house.
Yep.
And what it's doing is spanning that big opening over the kitchen, am I right?
Correct.
Over to the other side of that open stairwell, because there's no vertical wall in the stairwell. It's a big open wall the way we've got it designed. And so that girder truss is probably taking load from the roof line, but I suspect there might be a shear component as well with that girder truss.
Yep.
Because we're trying to make sure that the wind isn't blowing the house sideways, and that girder truss is going to be a stiff member in there to make sure that doesn't happen. Now, I'm no engineer, but that's my guess. It looks to me like we have some HVAC pipes. I'm not sure what green and blue means. That are kind of running right in the middle of the truss. So that's on the clash
return
report.
of supply is what we're looking at there, and we do color code this for you. So it's more evident when we're in this meeting.
So which is which? Blue is supply and green is return?
Correct. Yep, that's correct.
Okay.
So think of blue, cold air, right? So, and
Got
the
it.
green is the other. And we'll just kind of look at it. And like you said, it's evident that we have kind of that very limited space between the bottom core of that girder truss to the top of the floor truss that doesn't leave us room to put that in here.
Makes sense. So then in this meeting, Tim's our most experienced builder in the room. Tim, give us a range of options. What are 3 or 4 things that you've done in the past when you might find a collision like that? And sometimes we wouldn't find that until we get to the field. But in this case, we're able to do it on the computer. What are 3 or 4 options that you might go back to the engineer and say, what about this?
Well, in a high-end luxury custom home, you just replace everything with steel, and that solves all of your shear problem.
Yep.
But in this house, which is more of a mainstream framed all-wood house,
we're trying to make it more
we wanted to use
normal
wood
to build.
members.
Yep.
So then your options are some type of beam or the girder truss. And the beam is challenging because not only is there a lot of vertical load, but there's 6,300 pounds of shear load from wind. And the girder seems to accomplish both of those. It gives you adequate load protection for both. But as you can see, the girder causes the collision problem. And so yesterday, in discussion with the engineer, our options became drop the girder so that the bottom cord is below the bottom cord of the adjacent floor truss. But then that created a head clearance problem at the bottom of the stairs. So ultimately, through lots of discussions, Chelsea came up with a great idea, drop it a small amount, and change the composition of the girder truss to a more structurally graded lumber so the bottom cord doesn't have to be as tall. And so thereby we get the clearance between the girder and the adjacent floor truss, only having a small 6 to 8 inch drop beam at the top of that ceiling, at the bottom of the stairs, no longer having a head clearance problem. And if the architect feels like that's an acceptable solution to have that small drop beam across there, then Bob's your uncle.
And that's happening right between the kitchen and the dining room, so I think we can kind of turn that into a nice framed opening to the main space.
I wonder too, Chelsea, if that might make you go, hey, let's do a ceiling treatment in the kitchen or in the dining room, because then it gives us a really easy stopping point. You could do crown molding in that space, whatever, to try and make it look like it was intentional, rather than, oh shoot, we've got this issue we're dealing with.
Yeah, it's a new transition, really.
Makes sense. And I'd like to point out too, this allows us to not use steel, save the expense of steel. This girder truss is more expensive than just 2x4s, let's say, but way less expensive than us getting another sub in, putting a W14 by whatever in there in steel with a bunch of steel columns. This is going to end up being a really good cost-effective solution. And one thing that I think would be helpful for the viewers too is if you look at those two pipes, the way they come out from that direction, they're going into the truss space, which is over we're calling that the living room or family room, over the family room space. There's plenty of room for those ducts in that space.
Yep.
It's just when we drop into that floor cavity that's the problem. So it's
that
really
transition.
just that one transition that's causing that clash, right?
Yeah, exactly.
Got it.
So, and again, with collaboration, we're able to find a solution. Our next steps, we'd go, okay, Lindsay, this is what we decided. Let's go back to our designers.
Yeah.
Let's model that in and make the change.
And what's awesome about this, guys, is now instead of us finding the problem at the job site and the HVAC guy when he starts, 2 weeks after the framing's complete or whatever, going, Matt, Tim, Chelsea, we got an issue out here on the job. I got this girder in the way. Should we make a huge box down beam so that we can run this duct below the ceiling? Or do we call the truss engineer and say, hey, what if I made this big cutout? Let's do a big truss repair. Let's now bring in steel. That costs us time. That costs us money. It causes the HVAC guy potentially to leave the job for a week or maybe 2 weeks because he does a different job instead of ours. So fixing it here is in effect a $0 fix, right?
Exactly, $0 fix. And one thing to point out too is the customer experience, right? This looks intentional now instead of reactive.
That's right.
And what I love about Build Optimize, is we talk about building science. It's proactive, not reactive.
That's right.
And the customer doesn't feel that pain. And we've all had the phone call where your job stops and the customer's like, what's going on?
Right.
So
totally.
So we changed the experience for everybody involved.
Yeah, no customer likes seeing a Sawzall on a newly framed house. That makes us look real bad, does it not?
Well, what do, they take to Google, right? We've all dealt with it.
Yeah,
so
that's right.
Yeah.
Okay, so then what's the next clash we should look at?
Yeah, so let's go over to above the master and let's look at that run. So Kevin, if you'll kind of show that duct work over the master, and we'll see that we've got some interesting cording to get through here again with that being rigid pipe again.
Okay, so this is the bird's eye view looking from the top down.
Yep.
We've stripped the top Advantech decking off and we're just looking at the trusses from down. And again, blue is supply, green is return. And I'm also seeing some other...
ventilation's kind of that lighter green.
Okay, gotcha. So we have some ventilation pipes in there as well.
And we'll see what we have is we have our PEX, red and blue, hot and cold, right?
Okay, cool.
We'll see our electrical fixtures up in here. We were kind of talking about that earlier.
Oh, so that's a recess can we're seeing right there.
Yeah, it's a recess can sitting in there.
Got it.
But we'll see here as we're hitting some truss cords. Now, likely, can we move that up into the space and in that V part of the truss? Absolutely. But what we do got to check here is we got some restrictions in here. And so we'll have to get with the contractor just to make sure that we're not over-restricting the duct and losing the efficiency of the unit.
Yeah, and another thing I'd point out to you too is typically on our jobs we're using rigid duct for supply, and then we'll switch to flex on returns. We'll also typically drop the last 5 or 10 feet from the rigid trunk line and flex. So if this was our trunk line right there, this line would actually typically be running flex. So that would be no big deal for us to flex around some of those truss members. But this rigid pipe going through here that I think Gilbert told us was a 10-inch pipe last time.
10-inch pipe is what we had in there.
We do need a clear path for that to make it through.
We do.
Including the insulation on the outside of that 10-inch pipe.
Correct. Yeah. So we'll look at this and does it fit up in the V? Of course, like you said, for sound reasons, we have that last, footage that's going to be
10 feet or so.
That's going to be that flex duct, 10 feet. Thank you. So we can get around some of that, but we do have some collisions here that we'll have to kind of look at and then model. But we wanted to bring that up for you, the way that it was drawn with that rigid pipe from Steve. We're just showing, again, exactly what that was.
Yeah. The other area that I think would be worth looking at with the viewers is if you remember the floor plan, we've got our water heater centrally located. We used, Chelsea's been working with Gary Klein, our plumbing expert, to do a plumbing layout. Gary suggested very early on that we put that water heater kind of right in the middle of the house so we could supply the house with as little piped feed as possible, maybe eliminate the use of a pump. However, that made that area pretty tight, didn't it, Chelsea?
Mm-hmm.
Yeah, we got a really good representation of it here. So we can begin to see just how tight these spaces get. We did model in some chases for that in the truss, but we do have, with the cooktop being here as well, with the return of makeup air, and then trying to keep that kind of central, it's going to be a challenge for that. We can kind of see a collision creating here, so we definitely got to look in this space.
Okay. For purposes of today's video, we're not going to go into every collision and every fix, but as we get into framing, we'll probably point a few of those out to you later on in our episodes. Anything else we want to talk about today?
No, and Kevin, if you'll bring up the comments, one thing I do want to point out is that we will document. We have the ability to screen capture this.
Oh, cool.
Again, what are our solutions here? So we do document this, just so we have a reference point.
I didn't realize that report also is giving you like a snapshot of here's the problem and then a written description. Is that right?
Well, the written description's by us. So the snapshot came from kind of that report. We kind of then went in and looked at it. Now we're actually in here in the meeting talking about it, and here's how we're going to solve for it.
Got it.
Again, so it's written, so we have kind of a date time stamp of what decisions we made, and it's documented here.
That makes sense. And then my assumption would be once we make some of those changes, then you might go back to, let's say, the truss engineer and say, hey, we want to change this layout. We want to change the cording on this. Will you make sure that works? Sometimes there's a follow-up meeting with us, I suspect, right?
Yeah, normally, so we go back after this, we then remodel this based off of what we decided as how we were going to resolve it, and then we come back for a sign-off meeting. Post that sign-off meeting, then we'll issue the supplemental documentation, which we'll show after that meeting occurs.
Got it.
And I can't stress how important it is that we have our representation here, kind of your local OSR as well, that can translate kind of what we've done here back to the market.
Makes sense.
Yeah.
Because ultimately, once we get back to you, or once you get back to us and we sign off on it, Chelsea's looked at it, Tim's looked at it, maybe we bring our trades back to look at a few things. Once we sign off on that, we're pressing print, right, Lindsay?
That's correct.
And what's the turnaround time? I know this is a big question because we're talking to a whole national audience here, but from the time that we say, this looks good, how long locally and today, as we're filming this in 2024, does it take for us to schedule that framing drop?
So in the Austin market, now that we've got the design work good to go, and we hit print and go, it's going to be about a 2-week turnaround time to get material on site.
So in other words, while we're working on this, we're also working on the foundation. We just need to make sure that we're at least 3 weeks, maybe 4 weeks out, that everything is good, we've dotted our I's, we've crossed our T's, so that then we can send that to the truss team and the Ready Frame team. I visited a Ready Frame plant last week, actually in another marketplace, and I was shocked how cool and how impressive and actually how small the operation was. It doesn't take much. We've got a couple of cut stations and a couple people, and they're cutting the whole house, such that when you get out here, you'll see in our future episode, you're not going to see a saw running during the framing stage, and we're hardly going to have any waste because everything's happening at the factory. And in fact, all those cutoff pieces are going back into the system, so there's hardly any waste on the Ready Frame. So this entire framing that you see here basically looks like a jigsaw puzzle. It kind of looks like a Sears and Roebuck catalog house from from the 1930s when we were shipping houses on rail cars. This is super exciting for me.
Yeah. So just remember here as well, like you said, Matt, everything goes and gets pre-cut. So, we don't want the saws on the job. And again, we want this to be a quicker build. And again, it's the informed, educated builder. That's what we're bringing as information to you. And again, we can't stress how important collaboration is on this.
That's right. Let's switch gears because this is all the sticks and the bricks, but you've actually got another surprise for us, don't you, Justin?
Do,
You've gone to the next phase of the Digital Tools suite, which is called Configure, right?
Yes, we've taken that same model and we put it into here, and you kind of showed in the past, I think,
awesome.
in another video, but we can actually now go and again, I alluded earlier to the customer experience. Well, guess what?
Yes.
We're going to let the customer now go in and begin to then play with the fit and finish and customize it. So we'll just take a peek into the kitchen, kind of walk through the inside, but now we're beginning to then say, okay,
check that out.
Let's look at the fit and finish now.
That's our exact house.
Your exact house.
This modeling is using the framing that we actually have in your system.
Yeah.
So the bones of the house are correct per this model.
Yep.
And not only that, but we can, besides just walking around, we can actually play with this and make some changes with the customer,
Yeah, so
right?
we'll just go in here and let's just kind of change maybe the cabinet color real quick, and we'll see here that it renders it real time. So we went from kind of that tan to now that galaxy color, and we'll see that it changed that color on that island right down there. So it was tan like before, now it's the new color.
That's so cool.
So again, Home Configure is just that. We can go in here, configure it real time. To me, this is an evolutionary software that we do at Builders FirstSource.
That's pretty awesome. So we can change flooring, we can change paint colors, cabinet colors, we can change appliances, even down to, I think you guys have integrated with some of the suppliers that some of the plumbing fixtures and some of the electrical fixture options.
Yeah.
We can really get a very lifelike 3D rendering of the inside and the outside of the house and play with those finishes, even to the point where we could change the siding to brick or to rock or some other option on the outside exterior too, right, Justin?
Absolutely, yeah. So, and one really other neat feature is down here, you'll see that we can capture the snapshot. So how many times do we get in and we try and decide, well, which one do we want?
Which looks better?
Yeah, which looks better? Well, we can capture snapshots, and in the software we can start to compare it, and so you can see it side by side.
That's really cool.
One other thing to bring up too is that you, as the home builder, you actually get to kind of procure your catalog. We all have different kind of fit and finishes, the way we deal with our schedules and the way we deal with our specifications. Well, we put the power in your hand as the builder to control that product the customer sees.
All right, so if we don't want to show a Sub-Zero refrigerator, we can limit the customer to Samsung and Whirlpool and whatever the other options are as we render that interior. And probably the same goes with the exterior catalog, Lindsay, because you're not going to sell me something that's not available in my market, or I don't want to sell my customers something that I can't get, let's say. So we're going to show them options that are available at my local BFS yard.
Right. This is a customer selection tool. I mean, that's exactly how it was intended to be put out into the market. So,
I also see this as a huge sales tool, Justin.
Absolutely.
This house we're building, we don't typically do speculative houses, meaning I don't have a client attached to a job. This one is, because this is our Build Show Live house. We're capturing the filming. But if I'm a builder who's building houses that's going to be for sale, how awesome to have this rendering that you can say, Mr. Customer, this is what it's going to look like. Mrs. Customer, here's your kitchen, your master bath. Do you want to change those? We have the ability to change that. That's incredible. I mean, that's just really photorealistic.
Yeah, and historically as builders, how have we done it? We've had to build it. We've had to put the expense out.
Yep.
Well, we can get way ahead of the sales marketing cycle on this now. The great thing is that URL can be hosted on your website to look like your technology.
Yep.
And again, you're just accelerating that experience for the customer.
And on a nerdy side, for my nerd friends out there that I know are watching, notice we've got kind of normal looking overhangs, normal soffit and fascia here. But before, a few minutes ago when Justin was driving, we showed those clip trusses. So stay tuned for some of those details on how we're taking Monopoly framing, turning that into a normal house. And in fact, we're even putting a standard looking shingle roof on this house, even though we have a couple extra inches of Atlas insulation on top of the roof so that my roof line is totally thermally broken. This is going to be a really well-built house, but also I'm hoping to be very buildable so that you guys could go to your local BFS location and say, hey, I'm interested in building the Reisinger build, the Build Show house. I'd like to actually purchase those plans, and you could change or modify how you want, but then you could build the exact same house and build it to this really high standard of performance.
Exactly. You nailed it.
Justin, I think that's it, man. Super impressive. Thank you, BFS team, for this incredible visual. I think this really shows the power of the digital tools. Tim, Chelsea, I'm excited to get going on this construction project. It's going to be a lot of fun. Guys, stay tuned for the next episode of the Reisinger Build. We'll see you next time on the Build Show.